All right, so we're going to find the slope of the tangent line to the graph at the given point. All right, so what do we have for formulas? All right, the definition of the tangent line with slope m. We've got that formula we just wrote down. Okay, so you have to read the directions to know what formula we're using. So this is on the one on page 97. So we're going to use the formula from page 97, definition of the tangent line with slope m. So we use the part that says the m is equal to the limit as delta x goes to infinity or goes to 0 of f of c plus delta x minus f of c all over delta x. All right, so it says that the line passing through C, comma, f of c. Here's what I want you to understand. This is in the theorem. This is the ordered pair C, comma, f of c. This is the ordered pair C, comma, f of c. So if you, basically, I need to apply this theorem to this function and this point. Visually, I have a parabola. Visually, I have a parabola whose vertex is at 0, -4, and it crosses the x-axis at positive and -2, and I want to find the slope of this curve at 1, -3. That is the point. I would like to find the slope of that line right down there. Do you have to graph these? No. I am a visual person. I like to see the picture too. Okay? So I have this function, I have that ordered pair, and I want to find the slope of that tangent line, and that is what this formula will do. So I just need to apply this formula to that function and that point. So first of all, what is my c? 1. So in place of the c, I am going to put what? 1. So I'm going to be finding the limit as delta x goes to 0 of f of 1 plus delta x minus f of 1 all over delta x. All right, so how do I find f of 1 plus delta x? Where do I put 1 plus delta x? What's my function that I'm dealing with? X squared minus 4. Is it a big deal that this says g of x and my formula says f of x? No. Now it says f of x. Yeah, it's that simple. Yep, there you go. So have we done this before? Have we found like f of x plus delta x? This shouldn't be new. Where am I going to put this? 1 plus delta x. Into that x of that function. So that x is going to become 1 plus delta x, and I'm going to have to square it and subtract 4. Minus f of 1 means put 1 in for x into that function. I'm plugging these things into the function I'm given. Always. I plug c plus delta x and c into the function that I'm given. So now I'm going to subtract from it 1 squared minus 4. And it's so important that it's in parentheses. Then I'm going to divide the whole thing by delta x and find the limit as delta x goes to infinity. Don't worry, you'll see more of these today. This isn't the only one. All right, so now what can I do? What can I do with this? I've got to find the limit. Okay, we know how to find limits, don't we? I'm guessing that if I plug 0 in for delta x, I already can see that I'm going to have a 0 on the bottom. Here's what needs to happen every time. You're going to do some algebra, just like we've practiced since chapter P. You're going to try to factor out a delta x on the top, and you will be able to. and then cancel. Then you can use substitution and find the limit. Every time it's going to work like that. So what do I need to do? I need to FOIL out the top, 1 plus delta x. So that would be 1 plus 2 delta x plus delta x squared minus 4. And then I subtract, well, what's 1 squared minus 4? 1 squared minus 4, come on. It is negative 3. Minus a negative 3 is plus 3. Okay? That's got delta x on the bottom. Okay, tell me what else I can do on the top there. Combine the like terms. 1 minus 4 plus 3 is 0. Those all go away. Now, with what I have left on the top, can I factor out a delta x? Yes. And inside I have 2 plus delta x left. On the bottom I have delta x. What can I do? Cross off what? Okay, now, can I use substitution now? And what does that give me when I put 0 in for delta x? 2. And what is that equal to? What does it say that formula is equal to on page 97? It equals m. It equals the slope of the tangent line. 2 is the slope of tangent line. Thank you. All right, so let's look up at this graph again. Do you believe that this line possibly has a slope of 2? Wouldn't that mean go up 2 and over 1 and be on another point? Whoa, look at that. So the slope of that tangent line is 2. All right, so your very first homework problems, that's what you're doing. You are finding the slope of tangent lines using that formula. Okay, I'm going to do another one real fast, but we're going to extend it just a little bit. So not only am I going to find the slope of the tangent line, now I'm going to write the equation of the tangent line. Yeah, we're good. We're going to do one of these, and then I've got just a few little problems for you. So, all right. So now we're going to look at a problem. We want to write the equation of the line tangent to the curve, and this time our function is f of x equals 3 minus 2x. And I've got the ordered pair negative 1 comma 5. All right, so now you might think this is a totally different problem, but in order to write the equation of the line tangent to the curve, I need the slope. Because an equation of a tangent line is just y equals mx plus b. It's like we're trying to find the equation of that line now. Okay, now that we know the slope, we're trying to find the equation of it. And we can actually do that. Okay, so the first thing I need to do is find the slope of this at the point negative 1 comma 5. And so that would be the limit as delta x goes to what? No, the limit as delta x goes to 0 of f of c plus delta x minus f of c all over delta x. I'm going to write that formula down every time. Okay, so what's my c? C is negative 1. So I'm finding the limit as delta x goes to 0 of f of 1 plus delta x, negative 1 plus delta x, minus f of negative 1 all over delta x. So what am I going to put in place of, where am I going to put negative 1 plus delta x? into the function right there, into that function, yes. All right, so that's going to become 3 minus, oops, sorry, 3 minus 2 times negative 1 plus delta x minus, can you just make this easy on yourself? Can you just plug negative 1 in there and work it out like in your head? Plug negative 1 in, what do you get? 5. All over delta x. Still haven't taken the limit yet. Okay, what are we going to do on the top? Distribute the negative 2. So I have 3 plus 2 minus 2 delta x minus 5 all over delta x. Haven't taken the limit yet. What's 3 plus 2? Minus 5. So what's left on top? These cancel. So I have the limit as delta x goes to 0 of negative 2 delta x over delta x. What happens to the delta x's? And what's the limit as delta x goes to 0 of negative 2? It's negative 2. So what is the slope of this tangent line? M equals what? Negative 2. All right, so now let's back up just a minute and see if this is logical. What was this if you graph it? And what was the slope of that line? Negative 2. Didn't we just find that using calculus too? Yeah. Okay. It should be nice to know that, you know, calculus works even for linear equations. Now, do we have the equation of a line yet that's tangent? No. At the point negative 1 comma 5?
Almost like, since where it says f of negative 1, you know that f of c is 5 instead of putting it in the equation.
Yes. So like you're saying skip that step. That's fine. Yes?
Is it always 0?
Is what always 0?
Delta x is always approaching 0.
Delta x is always approaching 0. That's because you're always moving the 2 points together. You're making the difference go to 0, yes. So how would I write the equation now? Equation of a tangent line. Equation of a line is y equals mx plus, actually, I like point slope form. Y minus y1 equals m times x minus x1. What do we know about our tangent line? What's its slope? Negative 2. We just went to all that work to find it. And what point does it go through? Negative 1, 5. So can you write the equation of the line now? Okay. So y minus 5 equals negative 2 times x plus 1. Distribute. Add 5 and y equals negative 2x plus 3. How does that compare to our first equation? It's the same. Does it make sense that if you have a linear equation, 3 minus 2x, okay, so the y-intercept was 3, down 2, forward 1, down 2, forward 1, that at the point negative 1, 5, right there, that the tangent line is the same as the whole line? I won't have you do one of those. It'll be a little more work in the homework. So I don't have a bunch of problems for you to do. In the first ones, I just want to caution you on the first problem that I give you. Don't make it hard. Okay? Don't make it hard. Remember when I said what approximately is the slope of this line right here? Do you remember when I said that? And I just kind of went up 2, forward 1, slopes 2. Okay? Keep that in mind when you're doing the first homework problem. Okay? There's nothing fancy that you have to do on number 2. So your assignment is going to be to read 2.1. Yep. And to do page 103, problem 2, 3, 6